Hello everyone, welcome to Homework Help. If you find the videos useful, please subscribe to the channel. So in this video, we'll evaluate these limits that approach positive and negative infinity. So as per the problem, evaluate limit x approaches positive infinity for f at x and limit x approaches negative infinity for f at x. So we'll have to evaluate both limits for both functions. So let's start with the function on the left side. Now this is a rational function, and in order to evaluate the limits for infinity, we'll have to change this expression so that it becomes easy to evaluate these infinity limits. So for that, we'll have to analyze the degree of the denominator of this rational function. So the degree of the denominator is 2. So it's the highest power on x in the denominator. So that means we have to divide each term in the numerator and the denominator by x raised to the degree of the denominator, which is equal to 2. So we should divide each term in the numerator and the denominator by x squared. So we get f at x equals negative 5x squared over x squared, and then plus 3x over x squared over then 2x squared over x squared, and then minus 5 over x squared. Now we can simplify these fractions. So in the numerator, in the first fraction, the x squares get cancelled out. So we are left with just negative 5. And then plus, now in the second fraction in the numerator, one of the x's get cancelled out. So we are left with just 3 over x. And in the denominator, in the first fraction, the x squares get cancelled out. So we are left with just 2. And in the second fraction, we are left with 5 over x squared. Now we can evaluate the limit for this function expression. So we can write limit x approaches positive infinity, and then negative 5 plus 3 over x over 2 minus 5 over x squared. Now we can distribute the limit to the numerator and denominator, and we get limit x approaches positive infinity, and then negative 5 plus 3 over x over limit x approaches positive infinity, and then 2 minus 5 over x squared. Now we can continue on this side. So now we can apply the limit, and we get negative 5 plus 3 over infinity in the numerator, and in the denominator we get 2 minus 5 over infinity squared. Now we know that 1 over infinity is equal to 0, so in the numerator we get negative 5 plus 3 times 0 over 2 minus, so infinity square is also infinity, so negative 5 times 0. Now in the numerator 3 times 0 is 0, and negative 5 plus 0 is just negative 5, and in the denominator 5 times 0 is 0, and 2 minus 0 will be 2. So this should be the final answer for the value of the limit as x approaches positive infinity. Now we have to evaluate the limit x approaches negative infinity. So we can use this expression that we got after dividing each term by x squared, and we'll use the limit x approaches negative infinity. So the same expression, negative 5 plus 3 over x over 2 minus 5 over x squared. Now we can distribute the limit to the numerator and the denominator. So we get limit x approaches negative infinity, and then negative 5 plus 3 over x over limit x approaches negative infinity, and in the denominator we have 2 minus 5 over x squared. Now we can continue. Now we can apply the limit. So we get negative 5 plus 3 over negative infinity over 2 minus 5 over negative infinity squared. Now in the numerator, so we have negative 5, and then we get so the negative infinity in the denominator will just become 0, and it will become minus 3 times 0, because the fraction will become negative, and since infinity is in the denominator, so that's 1 over infinity, which is equal to 0. Now in the denominator, so 2 minus, so negative infinity square is positive infinity, and 1 over infinity is equal to 0, so we get 5 times 0. So this can be simplified too. So in the numerator, so 3 times 0 is 0, so just negative 5, and in the denominator, 5 times 0 is 0, so there is just 2. So we got the same value for x approaches negative infinity. So now we are done with the first function, so we can analyze the second function. So we'll start by analyzing the degree of the denominator. So in this case, the degree of the denominator is 4, because that's the highest power on x in the denominator. That means we'll divide each term in the numerator and the denominator by x to the power 4. So we can do that. So f at x equals, so 2x5 over x4, and minus 3x squared over x4, and then plus 5 over x to the power 4. Now in the denominator, so we'll do 3x to the power 4 over x to the power 4, and then plus 5x over x to the power 4, then minus 4 over x to the power 4. Now we can simplify these terms. So f at x equals, the numerator, so x to the power 5 over x to the power 4 can be reduced to just an x in the numerator. So we just get 2x. Now in the second term, the x square and the x to the power 4 can be reduced to just x square in the denominator. And then plus 5 over x exponent 4. Now in the denominator, so x to exponent 4 get cancelled out. So we're left with just 3, and then plus, in the second term, 1x in the numerator and the denominator will get cancelled out. So we get 5 over x cubed, and then minus 4 over x exponent 4. Now we can evaluate the limit for this expression. So we'll start with x approaches positive infinity. So limit x approaches positive infinity. So it's 2x minus 3 over x squared plus 5 over x exponent 4 over plus over x cubed minus 4 over x exponent 4. So now we can apply the limit to the numerator and the denominator separately. So limit x is positive infinity. So we get 2x minus 3 over x squared plus 5 over x exponent 4 over 9. The denominator, we get limit x approaches infinity, and we get 3 plus 5 over x cubed and minus 4 over x exponent 4. So now we can move to this side. So now we can apply the limit. So it becomes 2 times infinity minus 3 over infinity squared plus 5 over infinity exponent 4 over, so 3 plus 5 over infinity cube and then minus 4 over infinity exponent 4. So now in the numerator, so 2 times infinity will just be infinity, and then minus, then infinity square is infinity, and since infinity is in the denominator, so it's basically 3 times 0. And the same with the last term in the numerator, so we get 5 times 0 over 3 plus and then 5 times 0 and then minus 4 times 0. Now in the numerator we get infinity, and in the denominator we get 3. So infinity over 3 is just equal to infinity. So this should be the final answer for x approaches positive infinity. Now we can do the analysis for x approaches negative infinity. So we'll use this expression here. So limit x approaches negative infinity. So 2x minus 3 over x squared plus 5 over x exponent 4 over 3 plus 5 over x cubed minus 4 over x exponent 4. So now we can distribute the limit to the numerator and the denominator. So limit x approaches negative infinity, and then 2x minus 3 over x squared plus 5 over x exponent 4 over, then limit x approaches negative infinity, and the denominator expression is 3 plus 5 over x cubed minus 4 over x exponent 4. Now we can the limit. So in the numerator we get 2 times negative infinity minus 3 over negative infinity squared plus 5 over infinity exponent 4 over, so in the denominator we get 3 plus 5 over negative infinity cube minus 4 over negative infinity exponent 4. Now we can evaluate the expression in the numerator. So 2 times negative infinity will just be negative infinity. And the second and the third term will just become minus 3 times 0 and plus 5 times 0 because infinity is in the denominator. And in the denominator expression, so we get 3. So 3 stays as it is. And then plus, so 5 times 0. And then minus 4 times 0. So negative infinity cube is negative infinity. So actually this will become minus 5 times 0. So now in the numerator we are left with negative infinity. And in the denominator we are left with positive 3, which can be reduced to just negative infinity. So this should be the final answer for x approaches negative infinity. So these are the steps you have to keep in mind to evaluate these limits for these types of rational functions. So I hope you'll find this video useful. Please share it, like it, and subscribe to Homework Help. Thank you very much and have a nice day. Bye.